Visualizing our data is a great way to spot outliers and obvious errors in our data. Data visualization is more than just looking at patterns and reporting data. They can also be an effective way to spot outliers and plan your data cleaning pipeline. Here's the tabular form of summary statistics for a Clean European Environment Agency dataset. You can imagine how overwhelming the results can be on a dataset with many more columns. This is why it's important to visualize our data, because abnormal data points, such as the max population, would immediately stand out. We use bar plots to count discrete data and histograms to count continuous data. These plots will give us the ability to look at frequencies of our data, which can be used to look for potential errors. Here's an example of a histogram. We take the data frame and column of interest and call the plot method. We pass hist into the method to have pandas create a histogram. We have to make sure matplotlib is loaded before we can show the plot. Here is our histogram. The x-axis shows the range of values that are counted, and the y-axis is how many observations in our data are in a particular range of values. Our histogram shows 2 observations between 1 and 1.5 billion, and 1 observation above 2 billion. This dataset comes from 2012. At the time, it was impossible for a country to have over 2 billion people. We can slice our data to look for all data points where the population is greater than 1 billion people. We use bracket notation to slice our data, and inside, we specify the condition we are interested in: countries with populations greater than 1 billion people. Our dataset reports Australia having 2.3 billion people. This is a data error. China and India are also outliers in our data, but those values are correct. These countries are actual outliers. Not all outliers are bad data points. Some can be an error, but others are valid values. Let's see what this data set looks like in other visualizations. Box plots are a good way to visualize all the basic summary statistics into a single figure that we can use to quickly compare across multiple categories. You can see the DataCamp statistics courses for more information. We can spot outliers, the min-max of our data, the 25th, 50th, and 75th percentiles of our data. We create box plots by calling the boxplot method on the data frame. To plot just the population column, we pass it into the column parameter. We pass the by parameter the column name we want to compare box plots across. Here, I want a separate box plot for each continent in our data. Remember to show the plot. Here's the box plot of our population column. Most of our data is represented by the box. The lines that extend from the box are called whiskers. The ends of the whiskers show the maximum and minimum of our data, excluding outliers. And the outliers are values shown beyond the whiskers. You can see the 3 massive outliers of our data, one of which we know is bad data. The other 2 are actual outliers. Scatter plots are used to look at relationships between 2 numeric columns. In the exercises, you will use such methods to flag potentially bad data. You will also use scatter plots to identify candidates for bad data, which you will normally not see when plotting histograms or box plots, such as countries with low literacy and low fertility. This chapter will cover more of the gritty details in data cleaning. We begin with working with data types. Here's an example data frame. We expect the name and sex columns to be strings and both treatment values to be numerics. We can call the dtypes attribute on the data frame to get the types of each column. Here, you see that the name, sex, and treatment columns have a dtype of object, and the treatment B column is stored as an integer. The object dtype is a general representation in Python that is typically encoded as strings. Now that we know what dtype is stored in each column of our data frame, there may be times when we want to convert from one type to another. Numeric columns can be strings or vice versa, like our treatment A column example. We can convert the column to a string or object type, for example, by passing in the str parameter to the asType method of the column. Some variables, such as sex, are more than string objects. They actually represent different groups or categories. We can pass in category into the asType method to convert this column into a categorical variable. Here, you can see the changes to the dtypes of our data frame. For columns that contain categorical data, such as male, female in a sex, converting data into categories have a few use cases. They make the data frame smaller in memory, assuming you have a few unique values in the column. When you're ready to incorporate your data set into other Python libraries and analysis libraries, some of them can utilize categorical variables in their analysis. If we expect a column to be a numeric dtype, but has been loaded as a string, this is a typical sign of bad data that needs cleaning. In our example data frame, treatment A is stored as a string because of the missing value stored as a dash. In this example, we can use the toNumeric method on the column and the arrays parameter to coerce values into a numeric. This will convert all the values in the column into numeric. For invalid values in the column, it will be set as a nan missing value. If we do not pass in the arrows equal coerce argument, then Python will return an error because it will not know how to turn the string dash into a numeric value. Now it's your turn to work with data types in pandas.